you know what you're doing. So let's start with the GCF, okay? GCF is greatest common factor. Okay? Greatest common factor. So what does it mean to factor by GCF? It means that you're looking at all the terms in your polynomial, okay? And you're saying, what is the biggest number these guys all have in common, okay? Sometimes you can't do that off rip. That is okay. Sometimes it's a two-step process if you don't see the GCF immediately. That's okay, all right? I think this is best done by example. So let's do an example. This is going to be problem number 9 on page 100. Okay. Gosh. Okay. All right. So let's do problem number 9. Okay. If we look at problem number 9, it says 3x plus 12. Okay. Immediately we can see there are no x's. There are no variables in the second term, so we're not going to be factoring any of those. But what we do see is this is divisible by 3, and so is this guy, okay? If both are divisible by 3, we can factor out, we can undistribute, right? If we undistribute, if you take a 3 out of 3x by undistributing, right? Not quite division, but undistributing, what do you have left? You have x, right? 3 times x, you take the 3 out, it's just x. You open your parenthesis, okay. This is plus. There's no weird business here, so we can leave this as a plus. And what's 12 divided by 3? What's 12 unfactored of 3? If you take a 3 out, you're left with a 4, right? And that's it. Now, to sanity check your work, you're going to want to distribute it back out. So let's do that. I'm going to distribute it out. It's going to give you 3x. You distribute it out, plus 12. And if this matches this, you're good to go. All right? Let's do another example. Let us do number 15. If we do number 15, you're going to get 12x. You start with 12x to the fourth minus 36x squared. Okay. So the first thing is we see that both terms have x's, and they're a pretty big exponent too, right? It's more than 0. And both terms are even. Now, I know how to do this off rip. I don't expect you to, so this might be a two-step process. You might start with, oh, I see that both of these guys are divisible by 12. Okay, they both have 12 as a factor. If you take 12 out, you end up with x to the fourth minus, because negative 36 divided by 12 is negative 3, x squared, just like that. But you'll notice, I'm going to say factor completely. There's something else you can do too. You're only halfway there. You're only perhaps living on a prayer. You notice that there's an x squared here. This is an x to the fourth. You can take x squared out of x squared, right? 1 times x squared is x squared. But you also know that x squared times x squared is x to the fourth. Probably should pick better numbers, but it's okay, right? So actually, we can take x squared out of both of these guys as well. And by that, I mean this is equal to 12 times x squared times x squared minus 3 times x squared, right? If it helps you to write it out like that, I encourage it, okay? Once you see this, you're like, oh, I could pop those x squares out. Just one, though, right? You only want to take 1 out because we're playing a matching game, yeah? You don't want to take this. I mean, you can. Just pick 1, okay? And that's going to leave you with 12 times x squared minus 3. Cool! And of course, if there's any like terms out here we want to combine, any multiplication we want to combine down, you can end this with 12x squared, x squared minus 30. Okay? Deeper into this class, there's actually one more step, and the step is actually going to be x plus root 3 and x minus root 3. Okay? But that's a different conversation. Okay? For our purposes, this is okay. All right? Okay. Okay. Now what we're going to do next is problem number 25. Okay? Problem number 25, and it says, factor out the indicated factor. So we want to factor out -1. Okay. Negative x squared minus 10x plus 7, and you want to take -1 out. Okay. My personal recommendation is actually to break all of the factors down. You know how when you're looking at, let's say, 36, right? You can write this as 3 times 12. You can prime factor it, and this becomes 3 times 3 times 4, which is 3 squared times 4, which is 3 squared times 2 times 2, which is 3 squared times 2 squared. You know how that's like a thing that you can do? That's actually how I recommend you guys look at factoring for polynomials as well. We want to take out a -1. We're going to want to write this in terms of stuff times -1, right? Because that's what we're doing. So actually, this I can write as, let's see, negative x squared is going to be the same as saying -1 times x squared, right? Plus negative 10x is going to be the same as -1 times 10x. Positive 7 is a little weird. That's okay, because this can be written as -1 times -7, right? And once you have all of their common, once you have that factor out, -1, -1, and -1, magically, not magically, mathematically, you can write this as -1, the whole thing times, or times the whole, okay, the whole, x squared, because you've taken -1 out. What are you left with? You're left with x squared plus 10x plus -7. Okay. Nobody wants to write all those parentheses. I certainly don't. Okay? So I'm going to rewrite this as, oopsies. I'm going to write this as -1, or you can just write the negative up front. That's also fine. Negative, parentheses, x squared plus 10x plus -7 is just the same as -7. And you're done. Okay? For grade scope purposes, let's see, we did number 25. So I'm going to have you guys do number 20. And actually, I'm going to torture you a little bit. So this is number 20, by the way. I'm going to torture you a little bit and have you do number 28 as well. All right? Oh, one thing I do want you guys to note is, do you notice how when I factored out that -1, the signs swap? This becomes positive, this becomes positive, and this becomes negative. The shorthand is you switch the signs, okay? But what we're really doing is we are factoring out that -1, doing it this way, right? And so I want you guys to do it like this until it's so muscle memory, it's boring and tedious, and you never have to think about it again, okay? Understand why it works, do it the long way until the long way becomes muscle memory, okay? And then once it becomes muscle memory, you swap the signs. Because that's what swapping sign means. You've muscle memoried it, okay? Okay, now this is like a mini skills session, okay? Okay, so mini skills, I'm gonna write real tiny, okay? Okay, maybe not that tiny. All right, so by this I mean, so we can factor out numbers and everything is fine. Or we can factor out variables and everything is fine. What if we have a whole term? Let me show you what I mean. Suppose I tell you that I want you to factor 3x squared plus 6, right? And you're like, duh, that's going to be 3x squared plus 1. Duh. But I'm like, okay, hear me out. Oh, I'm so sorry. 2. Duh. Now hear me out. Would you agree with me that 3 is the same as 2 plus 1, right? If 3 is the same as 2 plus 1, in parentheses, right? Then that means that this guy is the same as saying 2 plus 1 parentheses, x squared plus 2. Yeah? Okay. And if we distribute it without breaking that parenthesis, right? That is to say, and also when we're distributing, this is what we're really doing, yeah? What I mean by that is we treat this as one big unit, right? You distribute this whole thing here, right? That is to say 2 plus 1 times x squared, right? Plus 2 plus 1 times 2, right? These are the same, yeah? And so, as a side note, this is why the Punnett visualization works. Okay? Anyway, you'd agree these are the same, right? Well, if these are the same, then you can do something a little funny. You can say, oh, if I have x plus 1 times x to the third plus 7x plus, or minus, really. You can do minus. Sure, why not? Minus x plus 1 times pi x to the fifth plus 16. Who cares what pi is, right? Pi is just a number. It's just a number. Don't worry about it, right? If this can be written as this, and also this, and also this, because of this, right? What you can do is you can straight up just pop this guy out of both, right? Because at the end of the day, it's just a factor. To be fair, it's a binomial factor, but it's still just a factor. It's being multiplied. Anything you're being multiplied, just, right? Just, and if you, right? You end up with x plus 1 parentheses x cubed plus 7x minus pi x to the fifth plus 16. Amazing. Obviously, if you really want, sure, you can break this down, combine like terms so you can factor some more. I don't think you can, but ain't that kind of nice? Okay? Okay. Now, the reason why we want to do all that is because we want to get ourselves comfortable with factoring by grouping. Because not everything is as nice as GCF, right? Okay. If you go back to way back with polynomials and multiplication, right? A pair of two termed things, a plus b and c plus d, should give you a thing with 4 terms before you start combining things down, right? But when you start combining like terms, you don't actually lose any of the data. It just looks a little different, right? And let's do an example together. Let's do number 46 on page 100. This is the practice exercises, okay? What do we mean by grouping? We mean, let's say you have AB plus B plus 2A plus 2, right? We want to split this into 2 groups, right? We want to split into 2 groups so then we can do something silly like this. So we can do something silly like that, okay? Okay, and the key here, right, the key is you want both groups to have something in common, something big in common, so you just pull it out, right? And so, these have B's, they should probably stay together, and these have 2's. They should also probably stay together. If you mix it up, you should still get the same result, it just won't be as nice. You'll have to do some simplification and all, that's all. Okay. If you group these together, let's call this pink, let's call this green, call that Cosmo and Wanda. This is going to be the same as, oh, these both have B's, right? If it helps, you can always draw a little line down here, okay? So you can visually separate it. Sometimes you might see me go like this, and then like this, okay? Just be mindful, because if that's a negative sign, then you want it inside, okay? So like this and a little plus sign right there, okay? But for now, I'm just gonna separate it like because this is plus 2. Anyway, so for this piece, we can factor out a b. If we factor out a b, that leaves us with a plus 1 on the inside. Yeah? Plus, well, let's factor this guy out. What can we pull? Both have a 2, so we can say plus 2. And if we pull a 2 out of here, or out of here, you get a. If you pull a 2 out of here, you get plus 1. Now all of a sudden, they have these two in common, right? And that means you can write this as, if you factor out the a plus 1, just like with that 3 and the 2 plus 1 situation earlier, you have a b, right, because you take this out and put it here, right, plus 2, because this has been taken out and put here. And you're done. Easy money. Okay? Okay. For grade school purposes, okay, here we go. For grade school purposes, I want you guys to do 11 to 14. This is going to be GCF. I want you guys to do 23, 24. It's GCF, just a little bit longer. I want you guys to do 26 to 28. Do as they say. They already give you the factor. I want you guys to do 33 to 35. GCF. Once you see, it's actually pretty straightforward. 43 to 44. Factor by grouping. Please do part C for both of them. Okay, very important conceptual problems. I want 53 to 56. Again, once you get the hang of it, it's pretty easy. You might have to do a little rearranging. It's okay. And 62. Okay? So, you might have to rearrange for 62 as well, and that is okay. Alright? That is all. This is like a 17-minute video. Thanks, guys.